Okay, so in this problem, we're going to find the general solution to this differential equation. So remember, when you've got a system, the first step is to find the eigenvalues and eigenvectors. Then, depending on properties of the eigenvalues and eigenvectors, we'll determine what to do next. But for this, we're going to find the eigenvalues and eigenvectors, eigenvalues first. So we're going to solve this equation, or not, so find where the determinant is equal to 0. Okay, so the determinant is equal, in this case, to lambda plus 2, lambda minus 3 plus 4, and this is equal to lambda squared minus 3 lambda plus 2 lambda, so that's minus lambda, and then minus 6 plus 4 minus 2, and I guess this can factor as lambda minus 2, lambda plus 1, and we set this equal to 0, we get two eigenvalues. One we'll call lambda 1, that's equal to minus 1, and the other one, lambda 2, is equal to 2. Okay, so that's eigenvalues. Now to find the eigenvectors, we're just going to solve the equation, this equation, let me just write it out. It's going to be 3 minus 1. So now we're finding the eigenvector associated to the eigenvalue minus 1. This is minus 2 minus 1. Okay, so it's just this matrix here, but with a particular choice of lambda times xy equals 0, 0. Now this top equation, what is it? Well, 3 minus 1, that's 3 plus 1, so that's 4. So the top equation is 4x minus 2y equals 0, and the bottom equation is 2x, okay, minus 2 minus 1, that's minus 1, minus y is equal to 0. Notice the top equation is 2 times the bottom equation. You just want to check that because if you've done something wrong, chances are the equations are not going to be multiples of each other, and if they're not multiples of each other, it means you've done something wrong. So check to make sure these two equations are multiples of each other. That just lets you know that you've done everything right so far. If they're not multiples of each other, you've probably done something wrong, or you've definitely done something wrong. If they are multiples, you've probably done everything right. Okay, at any rate, they're multiples, so it's really just one equation. So the bottom equation says y is equal to 2x, and so an eigenvector associated to the eigenvalue minus 1 is going to be any vector where the bottom entry is equal to 2 times the top entry, except for the 0 vector. So v1 is equal to 1, 2. Okay, now we're going to find the eigenvector associated to the eigenvalue 2. So we have 3 minus 2, minus 2, 2, minus 2, minus 2, xy equals 0, 0. Okay, this top equation is x minus 2y equals 0, and the bottom equation is 2x minus 4y is equal to 0. Again, the bottom equation is 2 times the top equation. The top equation says x is equal to 2y, and so any vector where the top entry is 2 times the bottom entry, except for the 0 vector, is going to be an eigenvector. Okay, and then so for this case where we have two distinct real eigenvalues, the general solution is very easy. It's just x of t is equal to c1 e to the lambda 1 t v1 plus c2 e to the lambda 2 t v2. And for our particular case, so this is not how you would write it on an exam. I'm just telling you what the formula is in the case of distinct real eigenvalues. Okay, so for us, the way we would write this is the general solution, x of t is c1 e to the minus t times v1, which is 1, 2, plus c2 e to the lambda 2t, so that's 2t times v2, which is 2, 1. And then this is the final answer.